All right, hello everyone. Welcome to my channel. This is an educational channel where we try to fill you in on uh, some great theories of everything that can change your life by giving you a holistic framework to kind of evaluate all the various knowledge streams that you have coming in and to kind of give yourself some structure. Um, and Today is the 332nd video that we have done on Dewey B. Larson's reciprocal system of theory. And um, the basic thing about Mr. Larson's theory is that we live in a universe of motion. In Larson's system, the universe is not made out of matter. It's not made out of energy. It's not a universe of forces. In fact, all three of those things are just different kinds of motion. We live in a universe made entirely out of motion. And for Larson, motion is the relationship between space and time. That implies a reciprocal relationship between space and time. Ergo, the name of his theory, the reciprocal system of theory. And it is a system of theory, meaning that once you understand the system, you can apply it to any subject. Larson, through some of his books, attempts to show us how to apply it in different subjects. He has books on chemistry and physics and astrophysics and astronomy, and he's got a couple books on economics. He's even got chapters of a book on biology and psychology, religion, dream interpretation, and other subjects. And some of his followers have followed his lead and gone into subjects even further afield. Now, basically, time and space do not have any independent existence. They only exist together in motion. And motion is a fraction with time or space as the numerator and space or time as the denominator. Larson had two fundamental postulates, and the first one is by far the most important, and in it he kind of put some stipulations on space and time. Space and time are the same. They have the same qualities. They're just reciprocals of each other. Just think of 3 and its reciprocal, 1/3. 3 and 1/3, they both have the same quality, that being 3. But one of them and 1. And so in one it's 3 over 1, and on the other side it's 1 over 3. They have the same two components, but they are put together in different order. So that's the same thing with time and space. They have the same components, but they are basically inverses of one another. They're inverted. One is the inversion of the other. And both space and time have their three-dimensional quality. That's what Larson calls coordinate space and coordinate time. We're accustomed to three-dimensional space, not so much with three-dimensional time. Time and space also both have their scalar progressing quality that Larson refers to as clock time and clock space. We're accustomed to the idea of clock time. Time is always getting later and later and later and later, but in no specific direction. That is what Larson calls a scalar motion. Scalar motion is a motion that has a magnitude, but it has no particular direction. And Larson points out that scalar motion is what the universe is made out of. But it is a kind of motion that differs in kind from the normal motion that the legacy scientists are talking about, which is a vectorial motion. That's a motion that has a direction, northwest or, south. That it's motion that it has a vector. It is pointed in a direction. But scalar motion is a more fundamental kind of motion that does not have a specific direction. It only has a magnitude. And you can envision this using a balloon with dots on it. If you blow up the balloon, all of the dots are moving away from each other, but in no specific direction. That is a scalar motion. And that motion has been observed by the Hubble telescope, which has observed that all of the distant galaxies are moving away from each other. And if we, are honest with ourselves, we recognize that, our galaxy is not at the center of the universe, then we would have to also decide that our galaxy is also moving away from all of the other galaxies. So all of the galaxies are moving away from each other in all directions. That is a scalar motion. And that has not been acknowledged or investigated by legacy science. And Larson goes into it. And so, we have clock time. Time is always getting later and later and later, but in no specific direction. And we have clock space. Space is always getting farther and farther and farther apart, just like two dots on an expanding balloon. And then also, time and space are both quantized, meaning that they come in only discrete units. You have to have a full unit of space or time before you have any space or time. If you don't have a full unit, then you don't have anything. And if you have 1 unit of space in 1 unit of time, you have the speed of light. And so for Larson, that is called unit speed. 1 over 1 equals 1. And in the reciprocal system, 1 is at the center. Just like with 3 and 1/3, those are two reciprocals of each other. But if you multiply them together, that makes 1. 1 is at the center. 3 over 1 is on one side, and 1 over 3 is on the other side. Reciprocals always multiply out to make 1. That's quite different than legacy science, where the 0 point is actually at 0 motion. In Larson's universe of motion, the state of rest, the origin, the 0 point, the null point, the midpoint of this universe of motion is already moving outward at the speed of light in all directions. So that is how we make our measurements. This is the reference point. So if we're going to measure a speed, we measure it from the speed of light, plus or minus. And so in Larson's system, half of the universe is actually moving faster than the speed of light, which is what Larson calls the cosmic sector. And then half the universe is moving slower than the speed of light, which he refers to as the material sector. The material sector is the only sector that the legacy scientists know about. Take Einstein's dictum that the speed of light is the maximum speed of the universe. So he's only understanding the material sector, and he is uh, pretty much outlying the cosmic sector. But we can determine what's going on in the cosmic sector simply by inverting the roles of space and time when we cross that speed of light boundary. So in the material sector, you have coordinate space, 3 dimensions of space, and clock time. The clock is always progressing, getting later and later and later. But in the cosmic sector, if you cross that speed of light boundary, the rules invert and you have coordinate time, 3 dimensions of time, to go along with clock space. Space is always getting farther and farther and farther apart. So they are reciprocals of each other, and you don't have to have any access to the cosmic sector on the in the general situation to be able to figure out what's going on there, because you can extrapolate from the material sector, because the general picture is the same. Okay, so basically that first postulate is saying that we live in a universe made out of motion. Motion is the relationship between space and time. But this kind of motion is not the kind that you basically, think of when you normally think about motion. It's a scalar motion that is in discrete units and that is 3 dimensional. Okay, and then the second postulate is just that the universe conforms to the relations of ordinary commutative mathematics. Its primary magnitudes are absolute, and its geometry is Euclidean, XYZ coordinates. But that has been disputed by some of Larson's followers, and some prefer to use projective geometry rather than Euclidean geometry. That's not a full correction, it's just a revision, because Euclidean geometry is a subset of projective geometry. And so it's just making it more inclusive. Projective geometry includes Euclidean geometry, but it also includes metric geometry and affine geometry. So it's really like a geometrical cascade from projective to affine to metric to Euclidean. Okay, now today we're going to look at an article that Larson wrote that is, I think back in 1976, I think he put together this paper and gave it as an address in Minneapolis, Minnesota in August 20th, 1976. And it's called The Mechanism of the Universe. And it goes like this. The human race in its modern form has been observing the universe from the surface of this planet for something like 50,000 years, perhaps as much as 100,000. But only within the last 3,000 or 4,000 years has it had the capacity to analyze these observations and arrive at conclusions as to their significance. Yet, on the basis of this extremely limited experience, we somehow feel that we are competent to investigate events which, if they happened at all, happened 10 or 20 billion years ago, and other events which, if they are ever going to happen, will not happen for an equally long time into the future. This highly presumptuous undertaking, which goes by the name of cosmology, has thus far been left mainly in the hands of two special groups: the astronomers, who are the only ones that deal with objects and processes that persist over long enough periods of time to throw any light on the points at issue, and the theologians, who are the only ones that claim to have sources of information independent of experience. Since our discussion will be concerned with the scientific aspects of the subject, it will not only be feasible to give any consideration it will not be feasible to give any consideration to the religious contentions and to the non-scientific evidence that is offered in support of those contentions. It will be appropriate, however, to take a brief look at the information from which the astronomers are deriving their theories. From the planets, particularly the one that we know best, the one on which we live, we obtain one very significant item of information. It is now clear that the Earth is undergoing some changes of an irreversible nature, what we rather loosely call evolutionary processes. This point may not seem very significant, as it is now taken for granted. One should bear in mind, however, that it was not always taken for granted. On the contrary, during almost all of the history of the human race, the belief was that both the earth and the heavens are fixed and unchanging. The definite evidence of the existence of irreversible processes on the earth is important because it is positive proof that the universe is not fixed and immutable. It is a universe of change. Another result of the studies that have been made of our own planet is an indication of the time scale of events in the universe. By extrapolating the rates of some of the irreversible changes, such as radioactive disintegration, back to some assumed base condition, it has been found that there was a discontinuity of some kind about 4 or 5 billion years ago. This has been interpreted as representing the time of formation of the Earth. Here, however, we encounter something that we need to watch out for. Whenever we are attempting to assess the validity of scientific considerations, if we examine the nature of the argument in this case, we find that the conclusions do not follow logically from the premises. Radioactivity is not a property of the Earth as an aggregate. It is a property of the radioactive matter. If the calculated 0 point indicates an age, it therefore indicates the age of the matter, not the age of the Earth. This conclusion is not acceptable to present-day scientists, so they substitute one that is more to their liking. We should disregard it and recognize that the observations actually tell us nothing beyond the fact that there was a discontinuity of some kind 4 or 5 billion years ago. For present purposes, that is sufficient, as it establishes the fact that we are dealing with objects and processes that persist through billions of years. The definite knowledge that this is a universe of change becomes very important when we move from planets to stars, because there is little opportunity for direct observation of the changes that are taking place there. The time scale of astronomical events is so long that our observations give us little more than an instantaneous picture. But there are aspects of this picture that suggest change. And the knowledge that changes do take place justifies us in concluding, at least tentatively, that the indications of change are not misleading. However, our ideas as to the nature and directions of the changes have to be based mainly on assumption and inference. For example, stars come in a great variety of sizes and temperatures, but the great majority of them can be placed in a regular pattern known as the main sequence. In a universe of change, there is good reason to believe that this is an evolutionary pattern of some kind. But unfortunately, the pattern itself gives us no clue as to the direction of the evolution. It does not tell us which are the old stars and which the young. For an answer to this question, we must examine some collateral data. When we attempt to do so, however, we encounter one of the major problems of astronomy and the astronomical view of cosmology. These collateral items to which we turn for a resolution of the question do not agree. In fact, as I will bring out later in the discussion, most of the purely astronomical evidence contradicts the prevailing astronomical opinion. What has happened here is that a very tentative conclusion as to the source of the energy of the stars that has been reached by the physicists has been accepted by the astronomers as incontestable and has been allowed to override the astronomical evidence. The physicists have spoken, let no dog howl. This is an example of another of the things we have to guard against when we undertake a critical examination of any field of knowledge, a tendency to magnify the observational information in transmission between the isolated compartments in which today's specialists work. The physicists know that their conclusions in this case are far from secure, and it is probable that those conclusions would be thrown overboard quickly if it developed that they were in conflict with any physical information. But by the time they have been passed on to the astronomers, they have acquired the status of Holy Writ, and any doubt as to their validity is unthinkable. Okay, we're going to stop it there and resume this article next time. And Larson will get into discussing a little bit more about cosmology and the mechanism of the large-scale, structure of the universe. All right, thank you for tuning in today, and come back tomorrow and check out the next segment of this paper. Thanks for tuning in. Have a great night.